My life be like, ooh, yeah. My life be like, ooh, yeah.
What is up, guys? Welcome back to another episode. Today we are skipping the garage and I invite you to my development den. And today we're going to be discussing my emulation project, which I've been working on for the past 2+ years. It started out with the STM32H series. I started out with the 743 ZIT6, which was a quite large family of microcontroller, which I quickly scaled down to a VIT6, which I also recommended to another developer over at RusCFI. So I hope to see that board come to life someday as well. I also finished my firmware for the STM32H7 series last July, so if that's something you guys are interested in looking at, feel free to reach out and we can definitely share the source code for that. Today I'm just going to be kind of showing my journey and what I learned along the way in developing an emulator and the hurdles I kind of faced along the way. I am not an electrical engineer by any sort of degree means. I am not a coder by any sort of certification means. Everything I've done has been self-taught, self-driven, and I've used a lot of engagement with large language models to help me understand and to make things come together as far as coding goes. Everything's been self-taught, from the circuit designing, the PCB creation. Had to really up my soldering game as well as learn how to reflow stuff. So the latest revision that I have is the RP2350 emulator. I refer to it as my V7 emulator, being that it's the 7th revision I've made. You guys have been kind of following along and seeing that we have these cool little chip replacements. We also have, of course, the open source Alpha Emulator, which is the STM32 variant. And the reason I really wanted to open source this guy initially was just because it's a lot easier to solder these type of components. And I wanted to make sure that you guys at home that are chipping ECUs and whatnot had the opportunity to actually assemble and create these things on your own time and resell these things. A large passion of what has driven me to create these devices is the fact that there's a real monopoly in the tuning industry, especially in the Honda tuning industry, and devices are just way over fucking priced. I don't care what anyone says. A $200 emulator is fucking astronomical. Back when I linked up with Dimitri over at HondaVert, those emulators were going for like $250, and you know, smoothing things over with him, we basically, I talked him into respinning the board to something that we would use without loading the S Manager protocol onto it. So essentially, when Snake first came out, Snake was literally a clone of the HondaVert emulator. And the reason that we were able to drop the price so low was because Dimitri kind of withheld his stolen protocol for the Hondata software, because I wanted nothing to do with the Hondata software. I wanted nothing to do with lawsuits or anything like that. And it's just fucking wrong to steal other people's work. But I got comfortable and I got behind putting it out there and marketing it because I convinced him to drop the price tag on those emulators. So we were marketing those things for $129, which seems somewhat reasonable. But after you get into developing this type of stuff, you learn that the cost is fucking pennies on the dollar to create stuff like this. And I wanted to make sure that I could give back to the community. I did a lot of wrong in the community. I had a lot of things going on in my life that caused me to pour into the resale and the products that I was creating and shipping, and a lot of people weren't getting the stuff they paid for. They weren't getting it in a timely manner. It was a lot of grief. So I had a lot of fuck ups that I did along the way, and this is just part of my way of giving back. So I've been documenting the emulators, the burners, the EEPROM replacements, dating back, 2 years now when I started. So I'm going to kind of sweep you guys through some of that stuff, take you through a little website that I put together. The website wasn't made to actually be launched and, be of any real purpose as a website. It was simply created because it flowed so much fucking better than a PowerPoint, and it really helped to lock in all of my work and make it organized. So we're going to kind of sweep through that stuff together so you guys can see what I learned, where I went wrong, and where I started to get the right idea on how to make this stuff work. This is the V7. It's my baby. She is an RP 2350 emulator. And when I developed this emulator, the RP2350B was actually not available in the United States besides to some beta testers, and I had to get the chips from a Chinese supplier who had them on hand. And when I was working with these chips, Easy EDA, who I love doing all my PCB work through, didn't even have the part readily available. I had to send them the data sheet and request for that part to become available so that it could be sketched up and drawn. So I've definitely been working on this project for a while, and as you can see, it is not just a computer designed concept. It is the real deal. It's an actual physical device, and on top of it, I hand assembled this device. It's not something that I had JLPCB assemble. I had to outsource all my own components and hand assemble the PCB. So the idea here is going open source with this. I don't want to charge any money for these products. I'm not trying to collect money. I'm trying to present an alternative for people to have low-cost emulation tools. I'm trying to put something out there so that other people can build these tools from scratch. And I want to leave it open source because I think that's the best way to improve devices. All these other guys are so closed source that they don't share the concept, they don't share where they can improve, they talk shit about their designs. Like, please, by all means, talk shit about my designs, but the fact is I'm just a guy who's throwing this shit together and making it work. And by putting it out there, it allows people that have way more intelligence and knowledge than I do, or creative thinking, that they can respin this as many ways as possible, and we may see a plethora of these alpha emulators come out into the marketplace. And I think that would be really neat, and I think that it would allow people who have the business strategy, the merits, and the community to provide a device like this to the community. I think it's going to open up a lot of doors. I'd rather see someone big, like Hunter Tuned or something like that, Dirty Tuned, these other guys. I want to see, PFI Speed. I want to see people pushing products that are officially theirs or branded as theirs, and they're low cost. As you guys have seen, chip tuning has been drying up for quite some time. People have had a lot of issues getting genuine chips, and as a matter of fact, these guys right here, these are a PLCC32 footprint chip. So you guys have definitely seen on the market in the past couple years something that looks similar to this guy right here. And the markup on it is fucking ridiculous. We're talking $20 to $40. It cost me like $1.50 to produce this fucking chip. $1.50. And that's with genuine shit. Genuine parts. So I'm really wanting to revive the tuning era. I'm wanting to get the stuff out there. And other than all of my hard work on the project, I have to give credit to my friend Dennis and colleague. Um, he hands down has motivated me and driven me so many times when I wanted to back out of the project and been overwhelmed by it and felt like I've gotten nowhere on it. He kept me alive in the project, and he is the one who is actually coding the entire firmware side of this RP 2350 device. I have coded up some code for this and run it and execute it, and I get some good reads and writes and things like that. But when it comes down to my concept for my data injection method that I want, since we're using a single NVRAM on here, I'm leaving that all to my buddy Dennis. He is the firmware god on this project, and I wouldn't be here making this video today if it wasn't for him working on the code to make this emulator come to life. So let's go ahead and jump into the previous revs, and we'll kind of talk about the stuff that's on an emulator, what you need, why you need it, and how it all ties together. And hopefully we can see a lot of people out there taking my hard work on the RP2350 and STM32 emulators and bring them to life. So come dive in with me. Alright, you guys, welcome to the Alpha Emulator database. So here you can find my trials and tribulations of the alpha files. The alpha files consist of my OBD1 emulator concept, my OBD1 chip burner concept, my OBD1 SST replacement concept. You can see my hardware designs and read through my journey. You can learn the Ostrich 2 protocol, and you can learn how to make your own hardware. You can view hand assembly and soldering of PCBs. I'm not looking to monetize my displayed work here. Instead of acting as a profiteer, I choose to open source my findings and empower the community. Hopefully more people begin tuning on their own PCBs. And I want to make it very clear, I am not advising people to market an emulator with the Ostrich 2 protocol. I am simply showing people how to use an existing protocol to make hardware into a working emulator. You should study the protocol instead and make your own protocol and submit it to some of the tuning software guys for adoption in their program. Open source the world. So hopping in over here, we'll take a peek at my emulators. So this is Alpha Emulator, the legacy. This is me showcasing the evolution of the Alpha Emulator hardware from my earliest concepts to the current RP2350 iteration. Check this guy out right here, revision 1.0b. This is my first PCB revision, and if we click on this guy here, you can see that we're in the specs over here. We have the STM32 H743ZIT6. I was using a 1 megabit parallel NVRAM, and I was doing DFU updates over USB-C. Essentially, this is my very first prototype, so it was extremely small in size right off the bat for my first go-around. And if we look over here, I have some notes. So this was my first PCB revision of the emulator. I was genuinely impressed by how compact it turned out, and I was even more thrilled when it successfully powered on and accepted firmware without issues. At the time, I was working heavily with some 1210 size components, so I stuck with that format along with a rather large STM32, which is, surprise, hiding on the backside. The board was riddled with vias and had tiny chaotic traces everywhere. Firmware could only be loaded via the DFU mode, and debugging options were extremely limited. My bad. But despite all of that, this was the original proof of concept. So yeah, this was my first alpha emulator. And to my surprise, it even fit inside of an ECU on the very first try. So yeah, I had to get this spacing dialed in and laid out on this footprint, and keep in mind the sensor that's over here on the side. It's the barometric pressure sensor, whatever it is, to make sure that nothing was going to collide inside the ECU.
It's the small design constraints like this that need to be accounted for, let alone the actual functionality of the circuitry. Oh, and get this, I did totally botch the schematic and I accidentally tied the regulator's VCC pad directly to ground. So I had to rip it off, slap some Kapton tape under it, and run a jumper just to bring it to life. Rookie move, but hey, it worked. Moving on, this was the 1.0C. This is my second PCB revision. This guy had the STM32H743 VIT6, which is a smaller footprint, and it also used that same 1 megabit NVRAM. So my second PCB revision took everything I learned from the first and I built on it. It kept a similar layout, but this time I went down to a smaller STM32 as well as adding an ST-Link and UART headers for proper debugging, which was a game changer. I also moved the NVRAM from the back to the front of the board, and this not only cleaned up the layout but gave me more room for thicker, more direct traces without making the board look like Swiss cheese from all the vias. Another improvement, I dropped a pair of resistors on the data line to help stabilize USB communication. And yes, I finally fixed that voltage regulator mishap. No mods needed this time around. This revision was a solid development board. With reliable debugging, clean uploads, I could finally start making real headway on the firmware for the first time. So yeah, side note there, that first PCB revision, I didn't even have resistors on the USB line. So that was a big mishap that actually caused me to have some really confusing sporadic garbage and data come in over the USB line. So another rookie mistake that I learned from. Moving on here, we got this big bad boy. I called this the V2 emulator even though it was my third revision, but it was because it looked so different and had a different technology to it. So let's check this guy out. I still use that same STM32. It's just hiding on the backside. And then I dumped a EPM 570 T144 C5N CPLD on this guy, as well as dual FRAM chips. They're the MB8R 256H. I was really turned on to these because there was no erase cycle required for the NVRAM, or excuse me, for the FRAM. So it was also super cheap. So the third PCB was a whole different beast. It pushed me harder than the last two, and it forced the design to grow in size and complexity. I started to worry that a single memory bank wasn't going to cut it for what I wanted to do. So I pivoted and added dual FRAM chips. That decision came with the challenge. How do you manage that many address and data lines efficiently? The answer ended up being a CPLD, which also meant adding a JTAG port to the board. I got the CPLD handling fast swaps between two FRAM chips without breaking a sweat, and it actually worked quite beautifully. But man, writing firmware for both the STM32 and the CPLD, trying to manage clock domains and keep everything synchronized, it all started to wear down on me. The board was physically big, the complexity was growing fast, and I found myself less excited to work on it. This revision taught me a ton, but it also made me realize I needed to simplify it if I wanted this project to survive. So yeah, if you guys have never worked with like VHL code and stuff, it's just totally different than working directly with microcontrollers and writing up C code. So I was totally having a curveball with that. I've kind of dove into it a little bit at work because we actually have CPLDs that we use to operate our lift systems. But yeah, I'm not a big fan of working with CPLDs. Boom. Check out this sexy beast right here. So you can see we're getting a little bit smaller in size here. This is my V4 board. It has that same MCU. I stuck with that STM32 basically the rest of the way through for my STM projects. I retained my original 1 megabit NVRAM, and I kept the USB-C for DFU updates and for doing the ST-Link. The big change here, as you can see in my keynotes, was I implemented bus transceivers and data latching. And over here in the about, by the time the 4th PCB rolled around, I finally rekindled my drive to finish what I started. So why not just reuse one of the earlier revisions? It's a fair question, and you're probably thinking, this guy already made a few solid boards. Why not just roll with one of those? The truth is, I tend to ship before it's ready to sell. The earlier designs didn't account for the ECU operating at a 5-volt logic. I was a bit naive, assuming it would all just work. Spoiler alert, it didn't. This revision marked a major leap forward. I integrated proper level shifting to handle the 5-volt logic on the ECU side. This version also introduced smarter hardware control. Now the STM32 actively determines when it can safely write to the NVRAM via a level shifted OE signal control rather than leaving it open to bad timing. I also tossed in a few more I/O pins to support possible analog inputs later on down the line. You guys can see that with the header right here. There were still some flaws though. The power traces were too thin for my liking, and when I cranked the MCU clock speed up to 480 megahertz, this board started getting toasty, even at idle. But that's just how it goes. Each version exposes a new weak link and forces the design to grow stronger. Moving on to the RP2350 first revision. This is my V6 board. It's a beautiful board. As you can see, I was barely able to get the LEDs to all fit on this guy here. Really enjoyed making this board. It's my first micro footprint, especially when you compare it to the very first PCB I made, which I thought was already a small emulator. Like, this thing just got dinky. So anyhow, we have the RP2350. It's a dual core chip, and I was using the typical W25Q128JV, which is just a standard 8-pin flash, and then still retaining that nice NVRAM 1 megabit. Love that thing. It's got a really dirt nasty write time on it. I love the store operation, and it's a readily available part. It's not obsolete, so definitely a fan of that. We went ahead and kept in those transceivers. Those are the SN74 LVC 8T245s. So those are an 8-channel transceiver, so you need a couple of those. And then I also used the 74 LVC T45 to monitor the OE signal coming off of the ECU. The main idea here was going to be doing direct injection. So the RP2350 stepped up to the batting plate for PCB revision number 6. And yes, we did skip the V5 red, which was actually just super mini as well, but it had major design flaws in the level shifters I chose. It was also STM32 based. If you guys want to see the V5 board, drop a comment and I will definitely show you guys what the V5 looked like. Once again, these are actual devices that I created. These are not just some computer schematics, 3D renders. I actually built this stuff, so I can definitely show you guys that. I have the PCBs around still. Anyways, so yeah, we skipped that V5 because of the major design flaw that I had in the level shifters that I chose on that one. I microsized the design substantially here, and I utilize way better grounding practices. So that's kind of what the textured surfaces you guys can see on the top is actually a cross pattern grounding plane, and I became a big fan of those as I developed other PCBs. Aside from the emulator circuit, I've developed quite a few other PCB boards. Again, if you guys want to see some of the other PCBs I've created for other projects, drop it in the comments and I would be more than happy to create a video on that. The RP2350, like its STM32 predecessor, is also responsible for determining when to write to its single NVRAM. I used many JST headers for the programming port and external expansion IOs. And here we are onto my baby. This is the latest and greatest. This is the Alpha Emulator V7. So we are rocking that RP2350B chipset. This is got very minimal changes, but they are there. As you can see, my LEDs look a lot more clean on this setup. They're not just barely touching on the board. We'll go ahead and jump into the about on this guy. So the V7 revision builds upon the successful RP2350 platform from the V6, and this version introduces the RP2350B, maintaining the dual-core architecture while focusing on expanding connectivity and refining control logic. The key improvements here include the addition of more expansion headers for greater flexibility, dedicated and proper OE output enable control to resolve the issue from the V6, as well as I isolated the shifter control logic for more robust and reliable data handling. These advancements make V7 a more mature and versatile emulation platform. So this is kind of the history here. You guys can see all of these different boards that I have created. This is my most current setup right here. As you can see, the V7 Alpha Emulator RP2350 is fully operational, featuring direct injection via its own dedicated core, data logging on board as well, and analog input for flex fuel and widebands, as well as support for analog output for things like non-VTEC ECUs that need relay control. So the JST headers on this definitely allow expandability. I also was using one for programming header for boot and reset, and this is my most current device, and as far as I know, I am the original author of the RP Pico chip on the emulator for a Honda OBD1 ECU. I do have other hardware that we can go ahead and check out in a little bit here, but I just want to kind of hop over here to JLPCB. And scrolling down here, you guys can see that my V7 board right here was actually put into production back on July 23rd. So that came some time ago. Going back even further here, this is that V6 that we were looking at. You can see I got a little mini programming header there next to it. The V6 design was produced back in January 21st of this year, and really going back in here, I got burners, chips. Look, here's the V4. The V4 was produced in December of 24. Looks like we can do a sneak peek now, actually. Here was that V5 emulator. It was also quite small. I had all kinds of components tucked together, so there it is. There's the V5. It snuck in there. And that guy was produced back in December 3rd of 2024. I also had a V3 that I never discussed or showed, a real one, V3. This was a 6-layer board. It was a crazy project, and as you can see, the order was canceled. There was a lot going on with it. I had tons of traces overlapping, and it was a fucking nightmare. So that one was definitely abandoned. Coming back in here further, we can see that the original board that I designed, that 1.0B, is right here. And that one was produced in June 22nd of 2024. So really what this comes down to is this is the Alpha Emulator, and I am Team Alpha, and I want you guys to use these products inside of your cars, and I want you guys to continue building off these products and introduce more RP2350 variants, as well as introduce STM32 variants. I want to see a plethora of tuning equipment out there at a low cost. I really hope you guys liked and enjoyed today's content. I hope that it encourages more subscribers and some comments below. Questions. We will definitely be diving more into the series on how to design this completely from scratch. You can see here I have some PCB software in the background. I would love to teach you guys more about the PCB design side as well as the logic required to make this type of stuff work. So catch you in the next one.